We just saw how to derive the derivative rules for the inverse trig functions, in particular the derivative of arcsine, arccosine, and arctangent. Next, we're going to look at how to use these rules in coordination with the chain rule. So what if you don't have arcsine of x? What if you have arcsine of 5x? Or arcsine of e to the x? How do you take the derivatives of composite functions involving the inverse trig functions? Well, recall that in general, the chain rule tells us that the derivative of v of u of x is equal to v prime of u of x times u prime of x. So for each of these three instances, the v function is going to be the stated function right here. So v of x would be arcsine of x. Except instead of doing v of x, we'll have v of u of x. So we'll derive a rule for arcsine of u of x. And the rule will be, well, it's just v prime evaluated at u of x. So we'll evaluate this at u of x. So x is replaced with u of x. Then we just multiply by u prime of x. So in other words, the basic derivative rules for these composite functions are the derivative of arcsine of u of x. So we just take the derivative of the arcsine as normal. So it's 1 over square root of 1 minus, except instead of the x, we replace it with u of x, which is the input right here. So 1 minus u of x squared. And then we multiply by the derivative of the inside function. So we multiply by the derivative of u of x. So instead of multiplying it up here, I'm just going to add this to the numerator. So times u prime of x. So applying the derivative rule for the chain rule to the derivative rule for arcsine of x, we get this rule for composite functions. The derivative of arcsine of u of x is going to equal u prime of x divided by 1 minus u of x squared. If you know the chain rule, you'll always remember this. You don't have to remember the actual formula if you're comfortable with and you know how to apply the chain rule. So then this one down here, we can proceed in a similar fashion. So the derivative of arccosine of u of x, well, this is just going to be the derivative of arccosine, which is negative 1 over square root of 1 minus x squared, except the inside function replaces the x. So that's going to equal minus 1 over square root of 1 minus u of x squared times the derivative of the inside, so times u prime of x. So in this case, we get derivative of arccosine of u of x is equal to minus u prime of x divided by square root of 1 minus u of x squared. And then finally, the derivative d by dx of arctangent of u of x is going to equal, well, derivative of arctangent is just 1 over 1 plus something squared, and then we multiply by the derivative of the inside. So exactly like that. So those are the three rules for computing derivatives of inverse trig functions that appear as a composition. So to do a quick example, let's look at, how about f of x is equal to sine inverse of 8 pi x. So what's the derivative of the arcsine of 8 pi x? Well, here the derivative is going to be f prime of x. Well, the derivative of arcsine is 1 over square root of 1 minus x squared. So it's going to be 1 over square root of 1 minus inside function. So that's our u of x. So 1 minus this squared. So 1 minus 64 pi squared x squared. And then times the derivative of the inside. The derivative of the inside is just 8 pi. So the derivative of arcsine of 8 pi x is 8 pi divided by the square root of 1 minus 64 pi squared x squared. So you see what happens the x here is just replaced with 8 pi x, so it's 1 minus 8 pi x quantity squared, and then you multiply by the derivative of the 8 pi x, which is just 8 pi. Another example, let's say we have arctangent of e to the 2x plus sine of 3x. Well, the derivative, you're just going to use the derivative rule for arctangent, 1 over 1 plus inside function squared, so, or 1 over 1 plus u of x squared. So it's 1 plus e to the 2x plus sine of 3x quantity squared, then times the derivative of the inside. The derivative of e to the 2x is 2e to the 2x. The derivative of sine of 3x is 3 cosine 3x. So chain rule used on both of those functions as well. E to the u of x, the derivative is e to the u of x times u prime of x. Derivative of sine of u of x is cosine of u of x times u prime of x. So the derivative of the inside is 2e to the 2x plus 3 cosine of 3x. So if our function is arctangent of e to the 2x plus sine of 3x, the derivative is just the derivative of the inside function. So the inside function's right here. So we just get 1 over 1 plus inside function squared, and then times the derivative of the inside function right there. So those are some two basic examples of using these composite derivatives of these composite functions. So no different than any of the other chain rule examples we looked at. You just apply the derivative rule as normal, treating the inside function as though that were the variable, and then you multiply by the derivative of the inside function.